You rarely act on impulse. The part of your brain responsible for stopping you from doing something stupid is also the last part to finish developing. That timeline is responsible for a significant percentage of human regret. The region in question is the prefrontal cortex, the front section of your frontal lobe sitting right behind your forehead. Its primary job is inhibitory control, the ability to recognize an urge, evaluate it, and decide whether to act on it. When it's fully online, you feel the impulse, the angry text, the impulsive purchase, the thing you'd regret saying, but you don't automatically follow through with it. What not fully developed looks like is the absence of that pause. The space between stimulus and response collapses, and behavior follows emotion directly. It's not a character issue, it's a wiring issue. The prefrontal cortex doesn't finish myelinating, meaning it's not fully connected and insulated until your mid-20s. For men, that timeline runs a few years longer, a fact that will surprise no one who has ever met a 24-year-old male. Before that, inhibitory control works inconsistently, and the gap between feeling something and doing something about it is essentially non-existent. When your frontal lobe is mature, the pause becomes automatic. You don't have to think about not texting your ex, you just don't. You can plan beyond the next week. To an underdeveloped frontal lobe, future you is essentially a stranger. And it turns out, it's very hard to make sacrifices for someone you've never actually met. Executive planning is the prefrontal cortex's ability to project your current self forward in time, to simulate future outcomes, set goals that exist beyond this week, and break them into actionable steps. The key word is simulate. When the brain does this well, the future feels tangible enough to motivate present behavior. Planning for retirement doesn't feel like someone else's problem. It feels like something that will actually happen to you personally. Without a fully developed prefrontal cortex, that simulation capacity is weak. Future consequences register as vague and distant, which is why short-horizon thinking dominates early in development. The brain defaults to what's immediate and concrete, not because you lack ambition, but because the neural machinery for long-range projection isn't finished yet. When executive planning matures, the future stops being abstract. Thinking 5 years ahead stops feeling theoretical and starts feeling like something worth actually doing. Planning for retirement at 22, to be fair, still feels a little like planning a trip to Mars, but at least you understand why it matters. You can switch tasks without meltdowns. Before your brain can shift attention to something new, it has to fully disengage from what it was doing. When that step gets skipped, the fallout looks like an overreaction, but the origin is purely mechanical. Cognitive flexibility is the prefrontal cortex's ability to disengage from one task, update priorities, and re-engage with something new without excessive frustration or shutdown. The process has two components: releasing whatever your brain was invested in and reorienting without dragging the previous task's friction into the next one. When cognitive flexibility is limited, interruptions don't just feel annoying, they feel completely destabilizing. The brain is still holding the previous task, hasn't fully released it, and is now being asked to process something new on top of it. The result is frustration that looks emotional, but is fundamentally structural. A mature frontal lobe handles this automatically. Plans change, tasks get interrupted, and priorities shift without the whole system coming undone. You answer the call, return to work, and don't need 10 minutes to recover your train of thought. It's the kind of flexibility you assume you have right up until someone tells you, plans have changed 5 minutes before you were supposed to leave. You tolerate delayed gratification easily. The marshmallow experiment is the most cited, most summarized, and most oversimplified study in popular psychology. It is also genuinely relevant here, which is unfortunate for everyone involved. The original study, conducted by psychologist Walter Mischel in the late 1960s, placed 4-year-olds in front of a single marshmallow and told them they could have 2 if they waited. What the recap version always leaves out is what Mischel actually found. The children who waited weren't simply more disciplined, they were better at cognitive simulation, the ability to make a future reward feel present and real enough to compete with an immediate one. That's what delayed gratification actually is. It's not willpower, it's the prefrontal cortex's ability to vividly represent a future outcome in real time, giving it enough weight to outcompete something happening right now. When that system is mature, waiting for the better option doesn't require white-knuckling through discomfort. The future reward genuinely registers as worth it. The modern economy, for what it's worth, runs largely on the assumption that this system remains underdeveloped in a significant portion of the population. The consumer debt statistics suggest that belief is well-founded. You don't need external control to do hard work. Self-motivation is a late-developing brain function, which is the most scientific explanation for why your parents had to tell you to do your homework 4 times. It wasn't entirely your fault. You were neurologically dependent on the reminder. Executive initiation is the prefrontal cortex's ability to begin an effortful task without being pushed. Task persistence is the same system's ability to sustain that effort without supervision, even when the task is tedious or slow to produce results. Both are frontal lobe functions, and both develop late, which is partly why schools and most workplaces are structured around the assumption that external pressure fills the gap where internal drive hasn't yet formed. When these systems mature, the machinery for starting and finishing hard things runs without requiring outside enforcement. You sit down to do the difficult task because your brain has built a sufficient connection between present behavior and future outcomes. The same prefrontal simulation that powers planning and delayed gratification now generates motivation directly. From the outside, it looks like discipline. From the inside, it feels less dramatic, more like a reliable ability to start things and see them through, without needing an audience, a deadline, or someone standing in a doorway asking why you haven't started yet. You regulate emotions instead of being hijacked by them. Your emotional brain processes a threat and fires a response in milliseconds. Your rational brain takes significantly longer. Every bad decision you've ever made happens somewhere in that window. The structure at the center of this is the amygdala, a region deep in the brain that processes emotional input and triggers automatic responses before your conscious mind has fully caught up. The prefrontal cortex's job is to receive that signal and regulate it, slow the reaction, evaluate whether the response is appropriate, and choose deliberately rather than automatically. This is called prefrontal limbic regulation. It doesn't only govern how you act when you're angry, it governs your ability to step into another person's perspective during a conflict, weigh fairness, and assess a situation from outside your own emotional state. When this system is mature, you feel the surge, the anger, the defensiveness, the hurt, and remain functional anyway. What a developed frontal lobe produces here isn't the absence of emotion. You're not calmer than everyone else. You simply have a longer and more reliable distance between feeling something and acting on it, and that distance is where every reasonable decision you've ever made was done. You can tolerate ambiguity. At a certain point in development, the brain becomes capable of holding a contradiction without needing to collapse it into a single clean answer. That capability arrives later than almost anyone expects, and the delay tends to be invisible to the person experiencing it. Abstract integrative reasoning is a higher-order prefrontal cortex function. It's the ability to hold competing ideas simultaneously, recognize genuine trade-offs, and reach conclusions without needing everything to resolve easily. The alternative, which appears in less developed frontal lobe function, is cognitive rigidity, a pull toward black and white conclusions, an urgency to pick a side, and real discomfort when a situation doesn't offer one. To a brain that can't yet process ambiguity, uncertainty doesn't just feel unpleasant, it registers as a problem that needs to be fixed, even when the honest answer is that nothing can be fixed yet. When this function matures, you develop a tolerance for gray area reasoning. You can hold contradictory evidence, accept unresolved questions, and work productively with incomplete information. You can also track context during a conflict rather than operating solely from your own vantage point. The most sophisticated conclusion a developed prefrontal cortex can reach is sometimes just, it depends. You course-correct your behavior after mistakes. There is a region of your brain whose entire job is to notice when something went wrong. It fires every single time you make a mistake, immediately, automatically, without any effort on your part. The part responsible for making sure it doesn't happen again is a completely different system, and it develops significantly later. The awareness side, noticing something went wrong, involves a region called the anterior cingulate cortex, which monitors for conflicts between what you expected and what actually happened. That signal fires reliably in most developed brains. What fires less reliably is what happens next. Behavioral change after a mistake requires metacognitive executive function, the prefrontal cortex's ability to step outside your own behavior, analyze it as a pattern, build a revised strategy, and implement that strategy rather than letting it stall in the insight stage. That last step is where the system most often breaks down. Intellectually understanding why you keep repeating something and actually stopping it are separate cognitive events. A developed frontal lobe closes the distance between them. It takes the conflict signal the anterior cingulate cortex generates and converts it into revised behavior. Not just in the moments after something blows up in your face, when you've briefly convinced yourself you'll never do it again. Consistently. which is a much harder ask than it sounds, and the reason self-awareness and self-improvement are not the same thing. You can see the big picture. A brain without a fully developed frontal lobe can understand cause and effect, but only when both are happening right now. The further out the consequence, the less real it registers. Future-oriented thinking is the prefrontal cortex's ability to trace a behavioral chain forward in time, to connect what you're doing now with where it leads, even when that destination is months or years away. It builds on the same simulation capacity behind planning and delayed gratification, but scaled up. You're tracking how a pattern of choices accumulates across time, not just holding a single outcome in mind. What this produces, practically, is the ability to recognize what a habit is actually costing you, not as an abstract observation, but as something that registers with enough weight to influence behavior. Knowing you eat poorly is one thing. Genuinely processing what that means in a decade is a different cognitive event entirely, and the frontal lobe is responsible for the second one. When this system is fully online, the big picture stops being an occasional insight you stumble into during a reflective moment. It becomes the default lens, the thing through which daily decisions get evaluated automatically, without having to force yourself to stop and think first. You can hold many moving parts in your mind at once. There is one cognitive function that predicts performance across nearly every domain it has ever been measured in, and you are almost certainly overestimating yours. Working memory is the brain's active workspace, the number of things it can hold and manipulate at one time. It lets you track multiple obligations, goals, and variables simultaneously without losing the thread. It's not long-term storage. You're not retrieving something memorized, you're actively holding live information while using it. When it's functioning at its highest, you can carry several ideas at once, keep them organized, and update your picture of each as circumstances change. Cognitive updating is the companion function, the ability to revise what you're holding in real time, rather than operating on outdated information because your working memory locked onto something earlier and hasn't refreshed. Together, these two functions are what let you remember a Wi-Fi password long enough to type it, correct yourself when you realize one digit is wrong, and finish typing it without starting over. The average adult can actively hold around 4 chunks of information at one time. The number of people who believe they're operating well above that average is considerably higher than 4. The frontal lobe finishes developing somewhere in your mid-20s, which means, for a solid stretch of your life, you were making fully committed decisions with an unfinished brain. The good news is that most of those decisions are now someone else's problem to deal with.